Hello everyone, welcome to part 3 of equilibrium and yield lecture video. We are focusing on this second table, which is on slide number 3, the final equilibrium concentrations and hence position of equilibrium for a given reaction depend on various factors. What you need to be able to do is that predict and explain using Le Chatelier's principle the effect on the equilibrium position of a system of a change in the concentration of a reactant or product, overall pressure of a gaseous mixture, temperature of an equilibrium mixture for which the delta H value, enthalpy change value, for the forward or back reaction is specified. You also need to be able to predict the change that occurred in the system or whether a reaction is exothermic or endothermic given the effect on the change on the equilibrium position of the system. So either you look at the change and then how it's going to affect the equilibrium position, or when you are told that equilibrium position changed, and if you are told that if it was an exo or endothermic reaction, you need to be able to predict the change that occurred. So basically those two. All right. Oops, not there. We are moving to slide number 18. All right. Let's start talking about what the Le Chatelier's principle means first. What's it called? French guy, scientist called blah blah Le Chatelier. He's got such a long name too. He came up with this principle that equilibrium, at equilibrium, there is a certain amount of each product and reactant, and altering the conditions that will cause a change in the amount of reactants and products. And a new equilibrium will be reached, that is, shifting the equilibrium position. It's kind of like, okay, just imagine that you and say 9 other people, so 10 people all in the room are just being confined in one container. The shipping container or something, but then you're suddenly told that it's gonna be hot in here, or we'll be putting 10 more people into it, or you're told that you will have another container right next to it and you can go into that as well. What would you do if you were that molecules within that container? That's what you need to be able to think about. Okay, and apply yourself to the molecular size, I suppose. Now, shifting the equilibrium position. If the equilibrium position is shifted to the product side, which is the right-hand side, then more products are formed. If shifted to the reactant side, which is your left, that side, more reactants are formed. Sounds easy enough, hopefully. Shifting to the right means that's the product side. Shifting to the left means more reactants being formed. Okay, the equilibrium position can be shifted by altering concentration or reactants, concentrations of each, you say, products and reactants, pressure or temperature. How would the system react? You can also click and watch the link that's above. That's a hyperlink for altering there. So go to your lecture note and click on it. Watch it. Come back to it later. So you should have learned how would the system react when it's at equilibrium but external change was made. On the next slide, it kind of summarizes what the Le Chatelier's principle says. It says, if an external change is made to a system at equilibrium, so that it is no longer at equilibrium, a net reaction will occur in the direction that counteracts the change. the internal change will oppose the external change. So, for example, the container metaphor, I suppose, where you are in. If the container was being heated up from outside, so external additional heat was there, then you guys inside will probably try to reduce the heat because it just becomes too hot. If you guys were sticking as couples, but if you are told that there will be another container attached to it and the doors open up, you're free to move between, then those couples will separate. You will probably occupy more room with that. Before then, you had no choice. Things like that can occur and happens all the time in a chemical reaction world, especially things that are at equilibrium. So change will always oppose the external change. There are 2 videos that I would show in class, so please also click on those links above there. Le Chatelier's principle part 1 and part 2, something that you should be able to pick up what that theory tells you. Yeah. And also, Le Chatelier's principle can be used to explain the shift in the equilibrium position when these are altered. Alright, now I might talk about this in the next video because it might become long if you were watching all those videos embedded. So I'll see you in a part 4.